morning for you, good afternoon for me. I am Professor Petra López. I am professor in Universidad Politécnica de Valencia, and I am engineer. My specialty is fluid mechanics, and I am going to speak about the application of CFD techniques to natural ventilation, in a particular case of the E3 building, which will be presented later. In our particular country, we have some problems of energy balance. And natural ventilation gives us a possibility to take profit of the environmental conditions of the buildings regarding to wind. In this particular case, we are speaking about modeling the airflow along the streets coming inside the buildings. In particular, computational fluid dynamics is a technique that can help us as technicians to give a more understanding of some issues involved with heating, cooling, and ventilation of inside the buildings. This will affect, of course, to the general energy consumption of the whole building. The particular problem is to model the airflow passing across different rooms in the building. In this case, the natural ventilation, the movement of air, plays an important role which is going to be used. It depends on the distribution of the building. It must have an atrium or a chimney to benefit the cross ventilation in order to let the movement of air inside the rooms. One very important aspect is to consider the windrows. We need to know which is the natural direction of wind in order to make an orientation of the windows and all the open space in the facades of the buildings. We have to consider the shape of the building and the surrounding environmental conditions of the wind to organize the windows and the doors in the facades. CFD, which is computational fluid dynamics techniques, can help us to know the influence of the flow behavior inside the building. The movement of the air, the possibility of dead zones or places in which the movement of air is very small, some recirculation zones or no ventilation parts of the rooms. The only way to visualization of the velocities of the wind is these computational techniques, as the velocity is a vectorial magnitude that cannot be measured directly. Why should we have a model of the wind? Because it can help us to save energy. But to know how much energy can be saved, we need a tool to quantify the velocity. The only tool to quantify the instantaneous velocity in every part of the volumes is computational techniques, as local velocities cannot be measured in any other way so specifically. CFD techniques will provide the visualization of the velocity magnitudes, direction, and the streamlines. And we can calculate the wind flow rate through the windows or any building openings in the facade to make a quantification of this natural ventilation effect. It's not my objective to show you many equations, but obviously the equation of the movement of air must be considered. Nowadays, we do not integrate these equations, but we use commercial codes to know those velocities. Particularly, we have used a commercial code called *CM+. But there are many others. We have ANSYS, we have many other CFD commercial codes that can be acquired and can be learned to be used. Any of them integrate those equations of continuity of mass and momentum of the wind and the energy in the movement. These equations can be applied to any sort of fluids. In this particular case, we're going to apply it to the movement of air along the buildings, passing around them and across them when it is opened. The models can be applied in a preliminary part of design. They can help us to take some decisions when we need to know any objective criteria for deciding the possible position of windows or opening parts in the facades. This modeling can consider the environmental conditions or the characteristics of winds. The methodology that we suggest is the next one. First, we have a preliminary design. We have to consider which is the shape of the building and an original orientation. We can do a computation with this code or whatever, and we can make these computations by making a geometry modulation, applicating the boundary conditions of the wind, generating a mesh, solving the equations, processing them, and giving some results. The interesting results are velocity streamlines, mass flow rates, flows coming in and coming out of the rooms, and temperatures. CFD can give many other results as turbulence, modifications on density, concentrations, and so on, but it is not the case in these applications. Are all the considerations of design compute? Have we all the possibilities considered? Then we must select. We could compare one to other design and taking a decision of taking more profit of the environmental conditions of wind. As we have mentioned, we have to make the geometry model, apply the boundary conditions, generate the mesh, making a solving process and a post-process. In general, the geometry model is 3D CAD design we need to define which is the original geometry of the problem. The boundary conditions are the conditions of wind and characteristic of the fluid, which is air, specified before initiating the analysis. The volume mesh is initiated by a surface meshing and a volume meshing. And then the solving makes a solution of numerical solution of those presented previously equations. And then the results will be post-processed in order to be visualized. We're going to apply such methodology in this case for the E3 building, which will be presented later. This building was going to be built in this campus of Universitat Politécnica de Valencia in a particular location. It is distributed, as you can see, a living room, a bedroom, and a corridor, and this is the considered geometry. It's in some sort of some unifamiliar house. The building will be surrounded by other buildings. This is the original place in which the building is going to be built, and we have to know what is surrounding it because it will affect the wind coming from the main directions. Two different alternatives are going to be considered. Well, in fact, three. The alternative one is not to put any lateral window. The alternative two is to put a right window. The alternative three is to put a left window in this part of the building. When we have considered the geometries that we're going to model, the next step is to define boundary conditions. Boundary conditions are numerical constraints that the model requires to compute. We need to have velocity inlets, pressure outlets, and all the watt and roughness definition in order to consider the movement of air. It depends on the characteristics of the geometry. We can make some sort of symmetry in order to save cells. In this particular case, we did a steady model with the steady state calculations. We used the gravity in order to define the buoyancy of the wind. Some sort of turbulence model, which is called K epsilon, trimmer volume mesh, which is the more convenient. And we have such a big number of cells validated with the consideration of Walleye plus, which is a parameter of turbulence. What about the orientation of the building? Well, this is the particular location in the university with the windroses, with the position of the main directions. And here we can see where it's going to be built. Which are the directions of the wind? Directions of the wind must be known of the windrows. The windrows is an statistical representation of the winds considered by direction and modulus for a particular case. In this case, the windrows for Valencia is mainly east-west. So these are the main conditions of the winter coming from the northwest, and the summer coming from the southeast direction. The more interesting condition to simulate is the coming from southeast condition, because it's in summer when we're going to need the natural ventilation close to the temperatures of Valencia city. The velocity of the wind is not constant in the vertical plane. It is exponentially growing. The characteristics of the wind depends on the height in which we consider this velocity. and it is variable. We must consider a medium situation, which never will be the particular instantaneous situation, as all the media. The componential mesh defined making this model is represented, while the details of the mesh. Just to illustrate how complicated the mesh it is, we have to mesh the surface, we have to mesh the volumes, and we have to mesh all the surroundings in order to consider the environmental control volume. Which results will we get? First, velocities. Velocities of wind. Consider the main direction of the wind and the possibilities of the other buildings. Also in the vertical plane, because it's three-dimensional modeling. Streamlines, which are the trajectories of the particles coming inside or going outside the rooms. When we have no lateral window, when we have a right lateral window, and we have left lateral window with different conditions of wind. We can also consider the flow of air across the open parts of the facades. With no lateral window, again with left window, and with right one. This will help us to quantification. We can compare how many volume of air is coming in and coming out, considering different cases of position of the windows. So we can decide which is more convenient. In this case, the Corys 3 is the best one because it makes the more path of air across the rooms. But what happens when the velocity changes? In this case, we have considered three possibilities of medium velocities with different exponential considerations. A medium velocity of 1.4 meters per second, 2 meters per second, or 3 meters per second. Why is this possible? Because velocity of wind is very variable. Some years there is very windy summer and the velocity as a media is much bigger than others. Environmental data is always non-constant, and it must be considered a possibility of a statistical change. Even in this case, when we have a left window, when there is 2 meters per second of velocity, in this window there is a path of flow. And where is 3 meters per second, there is a different path of flow. When there is 1.4 meters per second, the flow changes even in the direction. This means that it can happen sometimes going in and sometimes going out. What do we conclude of this study? Natural ventilation needs to be quantified because we need a tool to compare. The only way to compare is to have any parameter to be measured, calculated, or validated. In this sense, CFD techniques can help us, and they can give any sort of numerical result for quantification of velocity, flow, or temperature, which can give us any performance indication of the behavior in the building. In this particular case study, we have applied for a small change where to put the window. which could be the way to compare one to other geometry. And what we have considered is that it must be probabilistically focused, because the direction of the wind is variable, and it is also the modulus. Even depending on the velocity direction and the modulus, some windows can behave as coming in or coming out around the flow in the room. CFD will help modelers to identify the more convenient or inconvenient situations. And this is all that we wanted to show you. Thank you.